Today we're going to go through the more complicated topics in kinetics. And the major topic in chemical reaction engineering for your exam is the different type of reactors. So there are 3 reactors you need to know for the exam. The first one is the batch reactor, which is the simplest reactor. You have your plug flow reactor, and then you have your continuous stir tank reactor, also known as your mixed reactor, and I'm going to refer to it as the C-star reactor throughout the lecture today. So if you look at your reference handbook, each reactor has a set of different equations. These can be differential or integrated equations, and these start on page towards the bottom of page 237 of your reference handbook. You can see there's a bunch of batch reactor equations. We're going to go through all of those situations so you know when to apply certain equations. Now, these equations, and you can look at them in your reference handbook, they include some of your standard variables like concentration and such as concentration and the rate of conversion R, or your rate constant K. But they also include 3 other types of variables, and they are epsilon sub A, capital X sub A, and tau. Now, epsilon A is known as the fractional volume change at full conversion of component A. So it's the delta V over the total volume of your system. So let's say you have a reaction that goes from A to B. There's an initial volume before the reaction proceeds, and then there's a final volume when the reaction completes. So this epsilon can be found from that change of volume, and it can also be found using the stoichiometric coefficients of a reaction equation, which is the more common way to calculate it. Capital X sub A is your fractional conversion, and the formula for it is in the reference handbook. It's basically if I tell you that component A has a fractional conversion of 95%, then that means 95% of component A converted into a reactant. So that formula is on page 237, towards the center of the page, X sub A. And tau is specifically for plug flow reactors and C-star reactors. For batch reactors, it's just normally referred to as time, T. Tau is the space-time that you can calculate for plug flow reactors or C-star reactors.